We're asked to find local extrema, so local maxes or local mins. So to do that, we want to take a derivative and set the derivative equal to 0. So before we do that, let's just rewrite this function so that it's more derivative friendly. Okay, this is the same function, just rewritten. It's 3x minus 6x squared all to the negative 1/2 power. A square root is a 1/2 power, and we can move it to the numerator by just changing the sign of the exponent from positive 1/2 down here to make it negative 1/2. Now it's much more derivative friendly because the power rule happens. The negative 1/2 comes down and multiplies, so negative times negative makes a positive 1/2. And then we're going to keep the inside the same for right now before we use the chain rule. And the power gets reduced by 1 when you take a derivative. So now this is negative 3/2. And then we multiply by a derivative of the innermost function. So the derivative of 3x minus 6x squared, the derivative of 3x is 3, and the derivative of minus 6x squared is minus 12x. So there's our derivative. We could clean it up a little bit. We could keep this in the numerator, 3 minus 12x. That's a negative exponent, so now that we're done taking a derivative, let's put that back downstairs. So this is our derivative. We want to set that equal to 0 and solve. Sometimes we miss some key insights though if we have a fractional power. So one thing that people like to do is to rewrite it so it's equivalent, but it has no fractions for exponents. So we got 3 here. This is a square root of 3x minus 6x squared over 2 times 3x minus 6x squared all to the second power. Now check me out here, because look, this is the term in question. It's to the 1/2 power up top. It's to the second power on bottom. So if you do 1/2 minus 2, you get negative 3/2, right? Which is what we want in the first place. So these two things are equivalent to each other. I don't think it's going to matter either way with this question, but it's good to know how to do it in this form, because sometimes you miss something if you don't rewrite it without an integer for the power in the denominator. But let's just pretend we're going to keep it easy. We'll just do it up here. This is our derivative, and we said to find local extreme, you want to set it equal to 0 and solve. Okay, so you want to multiply both sides by 2 times 3x minus 6x squared all to the 3/2 power. Right, because we're trying to get x by itself, and we can't do that if it's in the denominator. So we're going to multiply the entire denominator both sides, which makes 0 over here. And it just makes 3 minus 12x over here. So if we keep simplifying, we want to subtract that 3 from both sides. And then we want to divide negative 12 from both sides. So we get 1/4 equals x. And so for this one, it's multiple choice. There's only one possibility, right? All these other ones have x is 1.5, x is 1, x is 1. So to make sure it's a local max, in case you have a multiple choice question where there's two options, we said our derivative happens at 1/4. So that's right around here. What you could do is you can plug in, let's see, make sure you don't have a divide by 0 error. We would if we plugged in 0. So plug in a number into the derivative, slightly to the left of 0.25, and then plug in a number to the right, but you can't have a square root of a negative. That's why I'm looking up here carefully. So we'll just pick some numbers that are really close, and we're plugging these into the derivative. So something slightly less than 0.25, let's plug in 0.2 into the derivative. Okay, we'll plug in 0.2 into either part of the derivative here. But if you plug in 0.2, we really just care about the sign of the number. It's actually easier to plug it in down here. So in the numerator, we got 0.2 times 12. 3 minus 2.4 is 0.6. 3 times 0.2. So we got 0.2 squared times 6. So 0.24. So in the numerator, I've got a positive number when I plug in 0.2 into the derivative. In the denominator, same thing, we got 0.2 squared times 6. And that's going to be 3 times 0.2 minus that squared. That's not going to change the sign. So we got a positive number in the denominator. So it's positive the derivative is positive to the left of our inflection point, and then we want to check the derivative slightly to the right to see what's happening. So let's plug in 0.3. So we got, if we plug in 0.3 into the numerator, so 0.3 squared times 6. Three times 0.3 minus this. So it's squaring 12 times 0.3. So it's going to be negative. So I plugged in 0.3 into the numerator. I got a negative up top. And actually, I forgot about this. If I'm using this form, that's what makes this form so good, is because if I plug in 0.3 in here, it doesn't matter what's inside. It's going to be squared, so it's definitely going to be positive. So we plugged in 0.3 into the derivative, and we got a negative number. Again, it doesn't matter exactly what the number is. We just want to know the sign of the derivative. So a positive derivative to the left of 0.25 means that we were increasing. And then a negative derivative means we hit 0.25 and now the slopes are suddenly going down. So this is a local maximum. But again, this is multiple choice. For this one, we knew it had to be 0.25 because that's what we got when we set the derivative equal to 0. But that's something you'll want to check if you have, if another option here said 0.25.